Hello, 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 hello. Welcome to yet another video. This one is going to be about 7D modeling of landscape. Well, you can probably tell from the title, right? And this is going to be a workflow that I use, and it's not necessarily the workflow that is the best one, but it definitely works for me. So sit down, relax, take a look. Maybe there's going to be something for you in here. I do have a starting point here, and that starting point is the contour lines that you usually get for your, either architectural, like proposal sites or any kind of a, urban or architectural project. And these come in, typically these come in flat, like that. So you will need to kind of move them up to their correct positions. And in my case, it was 500 millimeters between each contour, right? So I've done that. I also did the perimeter. And here we have, this kind of a three-dimensional kind of representation of the landscape. So now I need to create a surface from it, right? Or not necessarily a surface. I will make a mesh. There's plenty of ways of how to do it. The easiest one is actually to use Grasshopper. If you haven't used Grasshopper with Rhino before, don't be scared. It's going to be an easy, easy workflow. So let's type in Grasshopper to load it in. Oh, and also I have, while it's loading in, I have adjusted a few contour lines to fit the initial design of the building that I have here, right? So you can see that some contour lines have been changed. That's kind of a step 1.5. Let's say it like that. It doesn't really change any workflow that we're going to be doing from here on out though, so I'm not kind of focusing on it too much. Either way, once you have all of the contours, right, you need to reference them into Grasshopper. So I'll just do, not contour, goddammit, a curve component. Let me just quickly do bifocals. You don't need to do this or to use this. This is just for me to kind of get these labels in here so that you can see what kind of nodes I'm using. So I'll select all of the curves here in Rhino. Right-click on the curve component and choose to set multiple curves. Now they are linked, right, between Rhino and Grasshopper. Then for these curves, I want to create a mesh through these curves. So I will use, we can do discontinuity node for these curves. And you can see that what this continuity node does, it finds all of the corner points, all of the break points of the curves, right? So it just gives us a lot of, not information, but it gives us all of the information that we need to find where the continuity of the surface will change, right? So that's quite handy. And then from these points, and you can see we have a bunch of them. The problem is that for each curve, its points are placed into a separate list, right? So the thing that we get out of here, I can even show this to you. You don't need to do this, but I can show this. What we get out of here, this is like the list of the first curve that we referenced in. I don't know which one it is, but and all of the points in it. And then we have the second curve. You can see that the second list starts and so on, right? So they are all in separate lists. We don't want that. So to fix that, I will just right-click on the P output and choose flatten. This will force all of the points that we got to be in one single list. Then from here on out, I will be using Weaverbird's plugin. If you don't have it, get it. It's just Google Weaverbird Grasshopper and you'll find it. So Weaverbird, right? And in it, I will use what's called, where is it? I never use these Oh, sorry. That's my bad. It's not in Weaverbird. It's actually under Mesh. I thought that it was a part of the Weaverbird plugin. It's not. It's just under Mesh, under Triangulation, Delaunay Mesh, or Delaunay. I don't know how to pronounce that, but we are going to be using this Delaunay Mesh, probably. There we go. We connect points to points like that, and it gives us a mesh, right? And it's going to force the mesh to be in between all of these points here, right? So there is a problem, and that problem is, you can see here, for instance, this edge right here, or this line right here. You can see that it doesn't have any points on it, right? This whole segment, even though it is exploded up here, right? So that's the problem of discontinuity. Discontinuity by default, if two segments are completely straight, right? So the connection between them is seamless, it's not going to give you a point. So what we need to do is here, where it says level, instead of C1, which is tangent C, we need to use C infinite, which is 3, right? So I'm just going to double click on the canvas here, type in 3, like that, and just plug that one into L. That will always give us all of the points. You could use explode curve as well. That's going to work in a similar way. Either way, now we have ourselves a mesh, right? By the way, I'm hiding all of the points by just selecting the nodes and clicking my scroll wheel and choosing the blindfolded guy here. We have ourselves a mesh. Now for this mesh, I want it to be a little bit cleaner, a little bit nicer. So I'm going to go to triangulation here. I'm going to go to try remesh right here. So mesh, triangulation, try remesh. And I'm going to use this Delaunay mesh as my geometry input. And I'm going to hide it, right? So now I'm only previewing the try remesh, right? And I'm going to look at the other inputs. I believe I only need the length input, target edge length. Here I'm dealing with this in millimeters, so I'm gonna say something like 500. Why I'm using this dense of a mesh will become very clear very soon. But for now, I think this kind of works. I think we could use, features, optional additional curves or points to preserve? So what would happen if we connect our initial curves, all of these guys that we have here, into our features input here, like that? Not much changes. Sure, I guess that's fine. Anyway, this is the best we can do with the amount of detail that we have from the contour lines, or amount of the contour lines that we have. So I am just going to say this mesh is done. I'm going to bake it into my new layer, hit OK, and just disable preview of this one. And we can even disable the calculation of this one altogether. That's at 3 o'clock when you press the scroll wheel, like that. And then I minimize this and we continue working with this. Okay, so we have ourselves some mesh. Now what? Well, now we're going to draw in 2D. So I'm going to take this mesh and I'm just going to create a new layer. Well, let me create a new layer here as a sublayer and call it mesh. Change object layer and just hide it so that it's not in the way. There's kind of curves there as well. I wonder why. It's strange. Just a second. Getting rid of the unnecessary crap. So now we're going to do all of this in 2D, right? Because I need an initial idea for the design of how I'm going to tackle this. So the idea is, if we grab the building together with the contour lines, I'll just go to the top view and I'll just make 2D. Create, use make 2D command, create a drawing, and I'll just say plan, whatever. Scene silhouette, doesn't matter. I don't need much. I just need it as a guide right here, like a flat drawing. And actually all of the line colors should be by layer, print color by layer. Yeah, sure. That's fine. So this will kind of just let me choose where I'll be putting the sub-D elements, right? So it's going to drive my topology. So here I can just kind of draw out really quickly where I will want my path to be. And I think we're gonna do something like this. What is that? Sorry. What is that area right there? Yeah, that could be a staircase, couldn't it? Okay. So from there to there, I'm just going to kind of draw it out. So this is going to be my staircase area, and I'm going to have all of the kind of patches of sub-D going out from it, right? So I'm just going to kind of keep copying this like that, and it doesn't need to be precise at this point. Like that. So I'm just kind of creating a grid, and you can already see that it's as I'm making it, we're creating this kind of rectangular grid that if we follow, it's going to be all kind of neat and dandy, right? But that's a little bit later. The sub-D mesh is going to be neat and dandy. If I go back to top view, here we can start creating the sub-D mesh or sub-D geometry. Why do I have two V-rays here? You disappear. Okay, so the first thing that we do is we just create a single sub-D face. We need to start it off from somewhere. So I guess this is the best place. Let's create a new layer. New layer. Call this, call this sub-D. Now we're going to actually start creating the sub-D geometry, right? So the first thing that I'm going to use is under the sub-D tools tab, I will use the 3D face command or single sub-D face tool right here. So the shortcut, as I said, is 3D face, like that. And just make sure that the output is set to be sub-D. Everything else is kind of whatever. And I'm just going to create the first sub-D somewhere. I guess we can just kind of do it here. Oops. Make sure that intersection snap is turned on right here. And let's try again. That, and that. And then let's just hit enter for now. So this kind of a little polygon is created. If I hit the tab button, you can see that it changes its kind of proportions, not proportions, but this is basically the rectangular view is what you see here is a control polygon, and if I hit the tab, that's the smooth version, that's the actual geometry of the sub-D. So 99% of the time we stay in the control polygon view, right? So this rectangular view. One more thing that you might notice is that my geometry is red, and that is because here under display settings I have chosen for my object settings color backfaces to be turned on, and they are set to be red color. So in 3D I can see what's the back face and what's the front face, right? So if I select this and flip it, now this is going to be the front face, this is going to be the back face. For something like this, it won't matter as much, so I'll turn it off. but there are instances where this is a lifesaver. Just make note of that. Anyway, back to here. I will be using, I could kind of continue on going with 3D face and just kind of creating another one, well, making sure that it snaps, and then another one and so on, right? But I will try something new. I will try to use append face command. So I'll select the sub-D, enter, and it's going to ask me to pick point, but instead I'm going to say from edge, so F, enter. From this edge, and I'll just drag it out like that and hit enter, and then choose this edge, drag it out like that and hit enter, right? So you can always use this append command to quickly create polygons that are already joined. Well, except here, for some reason there it's not joined. I can tell by seeing the bold line right here that it's not joined. We will investigate that in just a second. But for now, I'm just going to kind of quickly go through this and create myself like a starting grid. Just like that. Okay, so there are instances where it's kind of messing up. I wonder why. Everything here seems to be okay. If it's doing the weird thing where it's not really connecting, like these 2 points are not connecting, right? What you can do is you can just select, well, go to the wireframe view, Control Shift and drag around where you know that you have 2 points that are not connecting, right? You can see that it immediately selects 2 sub-D vertices. And then you can use either join or stitch. Let's try join. Let's see if that works. Unable to join. Okay, sure. Let's use stitch. Stitch to average. And now this gets stitched together into 1 point. I'll do the same thing here. Like that. Stitch to 1 point. Usually I do this right at the end of my workflow. Actually, let me select everything except the sub-D, and let's just let's just lock everything in place. So all of the curves are now locked except for sub-D geometry. That's just going to make it easier for me to model out. So now there are no real rules of how to model this out, right? Usually what you want to do is, as you're creating these sub-D faces, you want to follow kind of along the contour lines, but it's not, you don't need to really focus in on the contour lines. You just kind of want to get a kind of similar shape to them. And also the corners, right? So this is where the building is, right? Where the base of the building is. So the corners are important. Usually for the corners, I do create a 3D face that looks something like this. And what this enables me to do, and we do one more here. Wait, is that correct? Because then we can do something like that. And here I'm just using 3D face because I can't be bothered to use append for in this instance. Sorry. But what it helps me do is it helps me create this kind of a nice little ribbon around the corner, right? So the edge loop, the center edge loop goes here and it makes a bend right here and will continue on, right? So I'm basically making a ribbon around my house in this way. If I were to create a polygon like that at the corner, something like that, the problem with that would be that imagine an edge loop coming in here and it just continues on there, and there's another one coming in from here and continues on there, right? It doesn't make a bend, it's just an intersection, a cross between two not edge loops, but kind of edge chains. In this case, the edge chain just kind of whoop, just makes a bend. So that's a nice little trick. Also, to join everything up, I'll just use the join command. Okay, so let me just do the perimeter and then we'll continue. So I'll just stop the video here. Okay, so here's the ribbon done. And that's usually what I always do, right? You have some sort of a footprint of a building. That's the first thing that you wrap around and you build up from there. You can see that every corner has kind of a very similar approach, except for this kind of a recessed corner right here. That's a bit different, but the logic of it is quite the same, right? So we have this ribbon. Now the next step is to fill in what's inside, right? So to fill all of this in, and to do this, you need to mix and match how many polygons you have on each side of the hole, especially if the hole is rectangular. If the hole is a funky form, and this I would consider a little bit more of a funky form, it becomes a little bit more difficult. But in this case, I will just kind of use append face and just see. And if I need to add more polygons on one or the other side, I will. But for now, I will just kind of try my best or do my best to recreate an inner patch. So I'll stop the video yet again, and I'll do the insides. Okay, so here we have a problem, right? I have 1, 2 polygons coming in from this side. I have 1, 2, 3, 4 coming in from this side. 1, 2 from here, and 1, 2, 3, 4 from here. So there's no way for me to create a proper grid. So I either need to add polygons on one side or remove polygons from the other. So I guess I'll be doing both. In this case, right here, I'll Control Shift. I'll just select the edge. When I say Control Shift, I'm holding Control Shift to select these two edges, and I'll just hit delete, right? That gets rid of those two particular edges right there. So now we have 1, 2, 3 polygons here and 1, 2 here. So I need to add an edge loop right here. So I'm just going to Control Shift double click on any of the edges along this edge chain and type in insert edge and just drag it down. By the way, offset mode absolute is like an offset. Offset mode proportional will create control points for the new edge at a proportion of each of the edges that they are sliding on. Right? So if we are doing midpoint with proportional, it's going to hit the midpoint for every edge, right? Right here, right here, right here. It's always going to hit the midpoint. With absolute, it's going to be more of an offset, right? So even if we're hitting the midpoint right here, you can see that all other edges are not being hit at their midpoint. So I really prefer using proportional for this kind of a task. Just click. We have now 1, 2, 3, 1, 2, 3. Perfect. Now for here, 1, 2, 3, 4, and 1, 2. I think what we might end up doing is I will create one triangle that will fix it a little bit. And also I will delete one polygon. And I'm thinking of, or not polygon, edge, or two edges. Rather, I will be deleting these two here, like that. So those got deleted. The lines that you see are from the 2D drawing. They're not from the sub-D anymore. So now I have 1, 2, 3, and 1, 2 here. So now to make these 3 become 2, all I need to do is create one little triangle. And that should fix it. Let's see how we can do this. 3D face, and just make a, let's make a triangle right here, just like that. And now you can see if I connect it like so, and like so. Yeah, I messed up that one. Let's try again, like so. We end up having 1, 2, 1, 2, right? So triangles solve, how do I call it? Amount of polygons problem, but also you should be very mindful that there is a triangle here, and triangles tend to be a little bit more problematic later down the modeling stages. So just keep an eye out for where you are actually creating triangles, so that you don't so that you don't dig yourselves into a hole. I'll just use append face from this edge right here. By the way, if you have problems creating enclosed faces, then make sure that, or faces that join into the rest of the sub-D perfectly, make sure that point snap is turned on. That will force the faces to be snapped to the points of the sub-D. It was vertex snap before, now it's point snap. I don't know, they keep changing it. And here I can see I have 2 vertices, so I'll just do a stitch to clean it up. Great. Now we have ourselves a little bit of a typology here going on. Now all I need to do is kind of just keep on pushing outwards and outwards and outwards more and more, right? To get nicer and nicer results. So actually, I'm going to use unlock, and I'm going to delete some of the contours here. I'm just going to say, let's make it clean, right? So I'm just going to draw out like a nice little edge here, and I'm just going to copy it to here, like that. And now all I'm going to do is copy it outwards by, let's say, 1 meter 500 millimeters, right? Then copy it outwards by 2, or what's 1.5 plus 2? 3.5, 3,500 millimeters, and so on. So now I have one edge right here, and you can't really see it. Let me just delete the line so that it's easier for you to see. Now we have one edge here, or one curve here, and then the next one is 1.5 meters away from it. Then we have a 2 meter gap between these two, and we can kind of keep continuing that 2 meter gap for 2 more steps. So 2 meters, 2 meters. Or then it becomes 4, right? Just like that. Perfect. Just a grid. That's all I'm making. So that's going to be kind of our underlying grid that we're going to be using. And I'll just extend. I'll just use extend to extend these bad boys right here. So they're kind of neat. And I will be slowly building up this grid with append sub-D, and I really want to align these points here, so I'm gonna do that first. I want it all to be neat and dandy. So I don't think that it's very interesting to to see the kind of the boring work or the manual labor. So I'm going to kind of skip ahead and show you this area built out. And trust me, it's important to first kind of do the topology so that later you can do 3D modeling very easily. So let me stop the video right here. So here it is. Right, and I've left one issue that I feel like I need to talk about. And that issue is right here. And there's two things actually that I want to talk about before we move on. The first one is you can see that this contour line right here and this edge chain right here, they kind of match up. That's I usually like to match up the first and the last contour lines. I don't know why, but I guess it's just I feel like I'm more in control that way. And I kind of tried to I drew these whiskers right here and right here, right? And I'm trying to morph between the grid and the last contour line right here, so that the transition is not as brutal, right? So that's one thing that I've done. And the next thing is right here, right? So let me actually drag out the sub D to show you the problem. Everything in sub D needs to match up perfectly. Every edge needs another edge to continue, right? If an edge doesn't receive another edge, then you will have problems such as these. And you can see when I hit tab and we get into the smooth shading of this, this is all messed up, right? So that's something that I usually see in like amateurs, people who are starting up with sub-D. They have no idea that, you know, the topology always needs to connect into a network. You can't just have an edge that arrives at another edge as a T-shape. So I'm going to fix this by just selecting these three edges and using insert edge tool right here. And I'll just insert an edge right there, right? Like that. And now to actually fix it, now we do have, you know, this kind of a nice transition going on, but to actually fix it, I will go into wireframe view, select like Control Shift and drag around the intersection point right here. And here in the command line, I can see that it's two sub-D vertices. So I'll stitch them together into one. Stitch, enter, and now this is all fixed, all neat and dandy. I'll get rid of, I'll get rid of this one and I'll just move the fixed one in place. There we go. Now we don't really need the whiskers anymore. Those are a little bit in the way, so I'm just going to select them and delete them. Get them out. Yep. There we go. Okay, so we have here you can kind of see that I'm working with a grid in an area that I'm going to be designing because I want it to kind of fit with the architecture of the building. And everywhere else, I'm just kind of trying to connect to the perimeter as cleanly as possible. That's all I'm doing. So I'll continue on with this area right here, and then once we have the clean topology, we will actually start modeling. There we go. So it's done. I will actually wait. Let's just double check. Okay, so we will be using this point as, you know, we will know that this point is exactly on the corner right here. This is just for me to move it properly, but I will move this away, unlock selected, and get rid of this all together because I want to kind of talk about the topology, right? So you can see that everything that goes around the perimeter, I'm keeping it very, very clean. I don't have a lot of polygons here, right? And that is very, I'm very mindful of that. And it's very important that we don't kind of start with an insane amount of polygons because that's just going to be a mess to deal with later. So now as I have a pretty nice 2D topology going on, I need to actually make it into 3D, right? Is there anything else I want to kind of mention? No, at this point, not really. If you're a complete beginner to sub-D modeling, I do have other tutorials and other workflows that I've been working on. So just check out, you know, on my channel, just type in sub-D modeling and you'll get the kind of the basics of it. I know I'm skipping over a few steps here and there. But now I will move this sub-D geometry to the correct landscape position, and I'll move it above my landscape like so, right? Then in layers, I will hide my building, and actually I don't really need to see my isocurves or perimeter. All I care about is the mesh, because I will take now these this sub-D geometry. I'll hit F10, or you can type in points on. I'll select all of the points here, and I will project them onto, wait, what? Oh, right, sorry. Another way of doing it. So the points on command was correct. It's just that you can't just select them like this, because it also selects the sub-D geometry. So we can't do that. So instead, I'm going to type in cell PT to make sure that only my sub-D control points are selected, and then I will use the project command, where it's going to ask me to select surfaces, polysurfaces, or sub-Ds to project onto. So that's my mesh, right? I select it, I hit enter, and it projects. And you can see that it messes up in certain places, and that is expected. That's because this it misses the mesh, right? That's fine. What we can do is we can just escape out of everything. We can Control Shift and double click on the perimeter that we have here, or on any edge of the perimeter. Control Shift double click, and holding down the Shift key, click on any of the handles in your gumball that scale things, right? So let's say the X handle right here. Click and type in 0.999 or 995. 99.5% of its original size. So we're just slightly, ever so slightly shrinking it down, making it a little bit smaller, right? We escape out of that. And then we repeat F10, cell PT, project, select the mesh, hit enter. And now we have a sub-D geometry that has been projected onto the mesh. And we have like the flat version of it as well. I don't care about the flat version anymore, so I'm gonna delete it. I don't really care about the mesh anymore, but I'm not gonna delete it. I'm just gonna disable the preview of it. But this is our now sub-D geometry that we're going to be continue on working with. Great. So now, when we have this, there are a few things that I want to design for and design with. The first one is there are regulations for the gradient of the landscape, how steep the landscape is, right? So for this particular site, I believe it's 14.2 degrees, something like that. So the landscape can't be steeper than 14.2 degrees. I need some sort of a tool that will inform me which areas that I have here are steeper than that. Also, as I'm looking at this right now, I can see that there are some areas where sub-D doesn't have enough resolution to approximate the geometry of the mesh cleanly. So I will add a few more polygons here. The way we do it is we will use insert edge. So I'm just going to use Control Shift, click on that one edge right here, let's say, click on the other edge right here, and then if you double click on any edge in between them, you will get the chain, right? And then I can use insert edge and just slap one in here, right? I'll repeat this for the other side as well. Like that, insert edge, just slap one in there. So now we have these two edges, edge loops, here and here, that need to be pushed onto the mesh, right? So what I'm gonna do is I'll just take them, I'll move them up like that. I'll do, I'll enable the mesh preview. I'll select the subd, hit F10, cell PT, cell points, but this time I'm going to unselect. I believe it's with control, right? Yeah, with holding down the control, I'm gonna unselect all of the points that are already on the mesh, and I'm only going to have these points selected, and I'm going to use project, and this time I will say that delete input needs to be turned to yes, or else it's just going to duplicate geometry for me. I don't want that. So delete input, yes. Direction C-plane Z. And yeah, then I just select the mesh and hit enter. And now this is much better, right? Now it's approximating the geometry much cleanerly. English, hard. Anyway, enough about that. Let's talk about more interesting stuff, which is the gradients, right? So 14 degrees, 14.2 degrees. We will use Grasshopper for this. Be prepared. And remember when I said that we will be using Weaverbird? Now it's the time that we're going to be using Weaverbird plugin. So in Grasshopper, we need to reference in our subd geometry. Subd, like that. Set one subd, just like that. So now they are linked. And I'm going to create a mesh from my subd geometry, right? So I'm going to extract control polygon, or actually let's do this through the menus, right? So it's under surface, subd control polygon right here. So extract it. So it's basically like a mesh, a low polygon mesh that approximates the control polygon that we see here. And then I will use Catmull Clark subdivision on it, right? On the control polygon with level 2, let's say. Something like that. This will give us more, not control, what's the word that I'm looking for? Just give me a second. It's going to give us more resolution. More resolution to actually measure the angle between the points. So that should be helpful. And at the end of it, we will be kind of coloring this mesh, right? So I'm actually going to move it. I'm going to use move command or move tool. I'm going to move it in Z direction. So unit Z, I'm just double clicking, typing in Z. I'm going to move it in Z direction by, any amount of millimeters. I guess I'm just going to use like 50 meters. So 50,000 millimeters. Is that too much? Yeah, that's a bit too much. Or maybe I should move it down. So it's gonna be negative. Negative, like that. And let's just have it somewhere here. Perfect. Okay. So now we have it moved, and now I want to color it according to how steep the hill is, right? So I'm going to say, what's the best way to do it? Let's do analysis, evaluate surface. No, we go for mesh evaluate, or we can do face normals. Yeah, let's do face normals. Let's check if that's going to work. If that's not going to work, I have another way of how to do it. So we're going to use face normals for the mesh, which gives us basically a center point on each of the faces, and it gives us a normal, right? And I can kind of, or maybe just using deconstruct mesh will do the thing as well. Apologies. I guess we can use, let's use deconstruct mesh instead. I just, in the middle of a tutorial, I figured out a faster way of how to do it. So we're going to use deconstruct mesh, which gives us all of the points, but also it gives us the normals for those points. And I can kind of show you vector display. I will show you those normals right now. You can see them here. So these are like arrows, and let me, you don't need to follow along with this. This is just me showing you how they work. Let's do 500, like that. They're like directions of the perpendicular directions from the points, right? That are looking outwards, right? So we can get those directions, and we can also measure the angle between these directions and the angle of a vector if these were laid out flat, right? Then we will get how steep the angle is. So if I were to deconstruct the vector, goddammit, vector xy, deconstruct vector, there we go. If I were to do that, then I have my x, y, z coordinates, and then if I construct vector only from x and y, and I take a gander at those, you can see that those are now, they're looking in the same direction, only that they are flat. So I'm going to oops, sorry. I'm going to, there we go. It needs to connect to the n, not to the v, the deconstruct vector node. I made a mistake there. But by the end of it, I'm going to measure the angle between the flat ones and these ones, right? So we're going to just say, and let me just delete that so that it's not in the way. So we're going to just say, okay, angle, this one right here, angle between two vectors, and let's measure the angle between our normals and the flattened normals, like that, right? It's going to give us an angle in radians, of course. I hate radians, so I'm going to use degrees, not that one, degrees command right here to plug in the radians to convert them into degrees, and you can see that it's like 89 degrees, 85, there's 76 in there, so there it's very high angle. So what we need to do is we need to use 90 degrees and subtract from 90 the angle that we get, and only then will we get the actual angle of the slope, right? Makes sense. So here, after the subtraction, that's where we get, you know, 0.6 degrees. There's like 14.5 degrees in one of those, I can see. So we get like an angle for each of these points. That's great. With those angles, I can create a color gradient, right? So I'll use gradient. I'll right click on the gradient and I'll say, just give me, you know, presets, and just give me this preset for now. We're gonna change it up later. And to create the gradient of colors, we need like the lowest limit. So the lowest limit is going to be 0, right? 0 degrees is going to be our safe color. Actually, this should be other way around. So let's find another green to red, right? So green is going to be safe, red is going to be bad. So 0 degrees is good. What's bad? At which color do we say that it's red? Well, the bad number is whatever gradient you have set as a limit, right? And in our case, it's 14.2 degrees, as I mentioned before, 14.2. It has different sites have different specifications. This one has 14.2, right? So that's our L1. And then our parameters are all of the degrees that we have for each of the points, like that. And thus we get the colors. Now, to actually colorize this, we do need to construct the mesh from the original vertices, right? So I'm just connecting it straight up from the original faces. But now I'm going to use the colors. Before it didn't have any colors, and now it does. So now we can see the mesh here, and let's disable the preview of everything except the final one. And let's amp up the Catmull-Clark subdivisions to level 3 so that it's a little bit cleaner. Let's go to display, preview mesh edges, turn that one off, and now it should be pretty straightforward, right? Okay, so we have ourselves a little tool that colors the mesh according to the gradient. The problem with the gradient is that it's a way to, like, something that is 12 degrees or even like 10 degrees is still going to be pretty red. So I want it to be much more aggressive towards the red areas. So we're going to have something like this happening, where it kind of goes slowly to the yellow, and then if it goes beyond 14 degrees, it just flips to red, right? So we definitely know where the problematic areas are. And at this point, what we do, by the way, if it's laggy, then just switch the level from 3 to 2. It's going to be a little bit blurry with 2, but it's going to be also fast, you know. So that's the trade-off that you get. Let's fix this little corner right here, and let me switch back to 3. I think my computer can handle this. Let's look at this corner right here. So how do you work with this? With the holding Control Shift, I can select different points on the mesh, or on the sub-D, sorry. So I can select either points or edges or surfaces, right? In this case, I'm going to be selecting a point right here, because I believe that that point drives the gradient, right? That creates this problem. So I'm just selecting that point, and I'm going to move it up ever so slightly. And you can use your own kind of numbers and so on, but here I'm just saying that, oh, more dirt will need to be piled in here, right? Like that, and we will need to lift that corner right there. And I'm just kind of slowly moving all of this up until I won't see any red. I really want to move this whole edge up though. Let's try. Yeah, there we go. So now this is yellow, but it's, you know, it's within the bounds, right? So I don't need to worry about it anymore. It's going to pass the inspection, so to say. A much more problematic area is right here. This is where we can't really model, we can't really readjust this, the slope. We definitely need to kind of work with it, or create terraces and so on to really get the gradient down. And that's exactly what I'm going to do. So the first thing that I want to kind of make is I want to sharpen up this, not polygon, how do you call this? Like I want to sharpen up this perimeter around my building right here. And I don't really remember where it is. I guess I can use the corner points to inform me. So I'm going to hide the building like that. And I think it goes something like this. Hope I'm correct. Like that. Yeah, seems like it, right? Yeah, that's perfect. So I just have this selected, and as I have this selected, I'm going to use Inset with a pretty low number, right? So I'm going to use like, I don't know, 5 centimeters. So Inset mode group, enter, 50 mil, like that. So you can see that the Inset basically creates inner offset. That is what Inset is, inner offset of the polygons, and this creates this kind of a protected boundary right here, all around the perimeter. If I hit tab, you'll see that this whole area sharpens up a little bit as opposed to what it was before, right? So this platform becomes a little bit more sharper. That is just my way of how I protect the borders, right? Then what I want to do next is going to be a little bit, I guess a little bit awkward, but I want to terrace out this area right here. So I'm actually going to, sorry, I'm just wondering where we should start from. I'm thinking of creating a terrace here. Well, first of all, this area right here is going to be the terraced for sure, right? So I'm just going to select these polygons right here, and I'm just going to flatten them out. So if you scale something along the z-axis to 0 height, right, it just becomes flat now, doesn't it? Like that. I'm just going to position it just like so. Right, so that got flattened out. And then this area right here, we do the same thing. Or maybe even like here. We flatten this out like that. Perfect. Then for this area right here, I also want to have it flat. I'm just wondering if I want it to be that that long, or even if I want it to be even longer. I guess we can do this whole area right here. So I'm just going to scale it down to become flat like so. And you can see that now this area right here is fine. The problem is right here, right? That's the problem. Don't worry, we will fix this. We will fix this, but for that we will need to create a few little spots here and there, a few borders, so to say. But for now, that's fine. Then let's do one more terrace right here. Flatten that one out to 0, like that. Maybe move it in a little bit. Something like this. And then for here, maybe we want to do something a little bit different. Maybe these 4 get flattened out. And this one as well. Get flattened out. And get moved to here. And then here we will have like a hill type of a situation. Then we have some sort of a partitioning here. You can see that in between we do have a ridge that is just kind of being destroyed. That is fine. We don't care. I can even delete the ridge if I want to. I will keep it for now though. So we have this flattened out, and let's just flatten out this area as well to 0. Just like that. Right? So we have this whole part flat. Then I wonder if we should do anything about this. Just creating some sort of a terrace here might solve a few problems. So I'm just gonna do it. Yeah, sure. Let's just do it. So let's go with the terrace until we reach the end of the site, right? Until we reach the border of the site. So we have something like that. Then here I will start deleting polygons. And I do this because I need a straight down edge, right? Because we're terracing it with kind of straight edges. So I'm just going to delete these, and is this flat? No, this is not flat anymore. So I'm gonna delete that and delete that. Great. So we have all of these polygons deleted. You can see that it messes up my mesh, but that's not a problem. We will recreate it a little bit later on. I'm going to take all of the edges that I have. You can see me selecting the edges on the top part of each of the platforms, right? Of the openings for the platforms. Like that, and I'm going to extrude them down, and the height of their extrusion doesn't really matter at this point. I'm just kind of extruding them down to create additional polygons. I'm going to do the same thing here, extrude this down, and same thing here, extrude this down, right? So we have something like this. Then I'm going to select, let's say this ridge right here, and I'm going to move M, enter, V, enter. I'm just going to move it up to fit with one of the, what's the word? One of the polygons that, or vertices that you have along this edge. And I think that I want to fit it with this point right here. So I'm going to try it again, move vertical from here to here. So M, enter, V, enter is a very, very strong tool to use. Keep that in mind. Like that. Perfect. And we kind of repeat it for this area right here as well. Move vertical from here to here. Perfect. Then all of these. M, V from here to here. And last one right here. From here to here. Perfect. Okay, so we have ourselves the terraces. Except this one. This one's ugly. I think I made a boo-boo with this one. Doesn't matter. We can just do it manually for each point. MV, right? MV. So I'm just kind of slapping every point in here. Yeah, now it's fine. So we've made this. It's not enough though. We need to, of course, stitch in and then fix all of the issues that we've created here, right? So I'm going to just bridge everything, right? So these three and these three edges, they match up, right? So I'll just type in bridge and create basically like a loft between them. You can think about it as if it's a loft, right? And then 1, 2, 3, 4, 1, 2, 3, 4, bridge. and so on, right? So I'm just gonna quickly do it. There we go. There we go. Oops. There we go. Okay, so we have this going on. Then I'm going to just kind of get rid of the opening right there, because that's we don't need it. We will have a staircase in there. Actually, it's going to go all the way through there. We're going to have a staircase there, so we don't need it to align. We don't need it to be present here, right? These triangles, though, I kind of want to fix them. I want to fill them in, so I'll just use fill command. Fill, select the edge, hit enter, and it's just going to create a triangle for you. Perfect. Now if I check, I can see that, well, it's making a mistake there, but most of it is contained within the ridges here, right? But the ridges, the problem with the ridges is that they are too soft, right? We don't want them to be as soft as they are right now. So what I'm gonna do is I'm going to select. You can either select the platforms or you can select the outer boundary. It's up to you. I'm going to be selecting the platforms, right? With thinking about it that it goes up, right? And I will just do inset. And let's do the same 50 mil inset. And you can see that it becomes sharper here, right? So I'll kind of repeat the process. Actually, when I think about it, I shouldn't select the platform itself. I should only select this. Yeah, that makes much more sense. To just have the retaining walls selected, right? Inset 50. So we have this much sharper, right? Same thing here. Select all of these, select all of these. Group 50, tab. We have it going. If you want this to be sharper, you can do a bevel on it. Just make sure that the bevel is not too intense, right? And then you will have your sharp break, but I don't want it to be that, so I'm gonna keep it as it is. Now when I take a look at it, there are some issues here with the gradient, but I believe we can solve them by just lifting up. Need to select both of these. Lifting up a few points, you know, to make it a little bit less intense. Just like that. So there's a lot of kind of small things. And maybe if we sink this point right down, yeah, that's good enough. I would say that's good enough. So we're kind of getting there, right? We have ourselves a little bit of a landscape going on. The staircase, though, I would suggest that you model out the staircase with regular NURBS geometry rather than sub-D. So for this, I'm just going to create like a box in which the staircase will be placed later on, right? So to do that, I can just do append face and just create it that way, but I think we can just do like that, move vertical, kind of slowly work it out point to move from. Slowly working out the topology of this by filling it in. I'm not gonna bore you with this, so I'm just going to skip ahead. Okay, so this is how it looks like. And it's very soft, right? That's the problem. It's way too soft. To be able to fit in a NURBS poly surface as a staircase, we need it to be sharper. And this is the only area where I do use crease, right? To sharpen it up, right? To make it actually hold its shape. So I'm just going to go around the perimeter here, just like that. And I'm just going to kind of keep creasing the edges. Nope. Yep. I'm gonna kind of keep on creasing the edges to kind of lock them in place. You can see how locked in place they get. It's going to produce some undesired results, undesirable results here in this area. Maybe if I remove crease from here, it's gonna be a little bit better. No, it's not. It's just, it's a price to pay, right? Perhaps if I were to do a crease here, that's gonna solve it. It's a little bit better, but still pretty bad. So that's why I absolutely hate using creases. They tend to be just obnoxious in terms of shading, in terms of how they deal with geometry in general. Either way, I will really quickly finish up here with creasing. Come on. I think I got them all, right? Yeah, it seems like I got them all. And if I were to look at this in the Arctic view, for instance, let's turn off the sub-D wires. You can see that the crease here does mess it up a little bit, but other than that, this looks decent. It looks just fine. So again, in here, I would suggest modeling out a staircase with NURBS geometry. I will not be showing you how to do that. I assume you know how to move some boxes around to create the stairs. And at this point, our little tooltip that we've created here will not work properly because we are starting to use creases. So I'm just going to disable it. And at this stage, I know that all of the gradients have been solved because here we'll have like concrete retaining walls, right? That will do the work for us. So I'm going to add a little bit more detailing to this. And afterwards, I'll just, once we're done with that, I'll call it a day, because that's the initial setup that I use. Any step after this is literally modeling with sub-D and adding more and more detail with sub-D, right? So for instance here, let me just quickly do that. Will I want more? Maybe I will want something like that. Yeah, let's go for something like this and maybe that. I will inset these guys right here that I have as groups, and I will inset them by a little bit more. Let's do 10 centimeters, so 100 mil, like that. And I'll extrude all of them up by, I don't know, like 50 by 5 centimeters up, and I will inset them again by this time 50, right? So this creates these kind of a slabs that we see here. And then if I were to go and take the corners of these slabs right here, and I were to bevel them, let's go for 50 millimeter bevel with one segment. By the way, I used one segment, offset mode absolute, and hit tab. Now my slabs are clean, right? And how clean are they? If I use emap, I can really check. They're less rounded, right? They're snapping into position quite nicely. So that's just one way of how you can kind of differentiate between materials by just making these kind of extrusions. And let me actually go through all of this to kind of clean it up a little bit. And also I really hate the crease here, like these creases here, so I'll just remove them. Better to just have like a shading issue there than to have it everywhere, right? So let's try select that, nope, that ZS to zoom selected so that it's easier to navigate with the camera, and then bevel. I used 50, right? Something like that, 50. And we have another island. So you can kind of play around with the islands as you wish. And let's say this one is higher, right? 100. So you can play around with islands, create tiling, create everything. And that will really work as long as you had like the initial topology done, right? So if the initial topology is nice, then all you need to do is just select the areas that you want to work with and just kind of extrude and push them in and extrude them down, stitch some areas together, and then so on to achieve, you know, any desired result that you want to. Let's see this pathway here. So I didn't clean up this pathway nicely, but I can always just say, okay, what if you go down and you want to go along this pathway here, right? I can just say inset group, sure, 50 mil, but actually let's do inset and let's not do group. Let's do mode single, 50 mil. So now it's insetting them all separately, right? Then I extrude them up by another 50 mil, and I inset them again by another 50 mil. So I get these kind of pluck, 3 little slabs here that I can go to subd tools and choose this edge ring tool to easily select all of the vertical edges here. And then use bevel on them with the same, I think I keep using 50, right? 50. Wait, I messed up. I think I messed up. Let's try again. Edge ring. Are you not going to work? Yeah, that's good. That's good. That's good. Enter. Bevel. 50. Perfect. Okay. That's that. That was strange. That didn't work before. And that is honestly kind of it. From here on out, all you need to do is just spend time on this, move things around, and make it work better. What the hell is going on there? Let's see. Oh, it's bending inwards, right? So that's those are the issues that you might expect from creases. That's why I really suggest not using creases unless you really have to. But it is what it is. I think we can kind of mitigate that by just dragging the slab away from the problematic area. Not really, huh? And then just maybe hitting this with a bevel. Just a slight bevel here. So the more you work with this, the more you will kind of learn how to work these things out. That doesn't seem to help though. I think the only thing that might help is adding another area here that would just kind of fix it, but I really don't want to do that. I guess I'll do, let's say it this way. I'll do a video number 2 where I'm going to detail this even further, and we'll talk about more stuff that I feel like are or is important. If you want to see, you know, part 2 of this video, let me know in the comments, because I'm still not sure if I want to do it or not. But that's it for part 1 at least. This is what we have. And let's call it a day. I'll see you in the next one. Later.